Here is a task, guys. If you're just joining, nice to see you, Angelo, by the way. If you're just joining, here is a function. F of x is equal to e to the power of ax. And I want you to find the derivative of the inverse function. I did not make it fully abstract. It's still possible to use a computer to find it. No? Junaid, why did you disappear? Oh, good. Nice to see you. And Francis, I haven't seen your face in a long while. Interesting, right? All right, guys, so how can we do that? Well, there are several. I'm going to first show you how to calculate it very easily with very little concepts. You ready? And afterwards, we'll try to do that with a few more examples. So, guys, what we are going to have is we will begin by saying that y is this function e to the ax. Yes? Or better said, let's begin this way. Let's set y equal to the function we want to take the derivative of, f inverse x. Yes? Then what do we have? Then we have, if we apply f on both sides, we have f of y equal to f inverse x, which is simply x. But what is f of y? F of y is the function. It's e to the power a y. Are you with me? Now, I can use implicit differentiation. I presume I have the formula for y. I haven't found the formula, but I presume I have the formula. Agreed? So then what do? I take the derivative of both sides. So the derivative of e to the ay is e to the ay times a dy dx, or simply y prime. You see, I took implicit differentiation, and that's equal to 1, which means what? Which means that y prime is equal to 1 divided by a y. Yes? Yes, but you can do even better. Look at it. What is EAEY? You see, we can do one step better. You see this? So this is this expression in y can be replaced into just a very simple expression, which is x. So the answer for the derivative is 1 over ax. 1 over ax. Understood? So this is using implicit differentiation, and in fact, very little thought. Very little thought, just understanding this type of thing. Now, here is another question. Here's another question. Suppose you have this function, f of x, equal to let's see. Equal to the cube root of 1 plus x cubed. Okay, that's my function here. I want us to find the derivative of f inverse x. Not of this function, but of the inverse. Can you do it the same way I have just accomplished it? There is no such thing as not good. Just if the answer is correct, it's correct. If it's not, then it's not. All right, guys, let's do it together. It should take you less time than it takes. So first, I mean, you might prefer to write this expression as 1 plus x cubed to the power of 1/3. Agreed? Now, what's the first step? In my class, or for any class where you think, the first step is y. And in this case, of course, the y is this. Y is f inverse x. You understand? I just label it with a simpler symbol. This is the expression for which I have no formula. Now, if I apply the function f to it, what should happen, guys? Do you see that on one hand, I apply the function f to y? That's the same as applying f to f inverse x, which is, what do I write on the right side? This is equal to f inverse x equal to x. They're just canceling each other, yes? On the other hand, if I plug anything into this function, what do I get? I get 1 plus y cubed to the power of 1/3. Whatever I plug in is cubed, you add 1 to it and you take the cube root. Yes? As simple as that. Now I take the derivative of this entire expression. What do I get if I take the derivative with respect to x? It becomes 1/3. 1 plus y cubed to the power of minus 2/3 times 3y squared times y prime. Flipped, I'm not sure what flip, I did not use, I mean, I have information about the function. Here is f. So I say y equals to f inverse, I apply f to both sides, and I have this expression. Yes, and then the derivative of y prime is what I seek. Y prime is the derivative of the inverse. So I use implicit differentiation, I write this expression, and it's equal to 1. And that means that y prime is equal to 1 divided by, you can see the 3's cross out, so divided by 1 plus y cubed to the power of minus 2/3 y squared, which if I adjust, y prime is equal to what? Y prime is equal to 1 plus y cubed to the power of 2/3 divided by y squared. Yes? Why is it equal to 1? Because the derivative of x is 1. I take the derivative of this equation. Look at it here. It's equal to x. the derivative with respect to x is 1. Yes, so we have this expression. Now I can recognize something, guys. Y is, I can simplify it quite a lot. Why is it equal to x? Because what is y? Y is the inverse. If I apply f to the inverse, they cancel each other out. Look at it. They just, what is this? F of y is the same as f of f inverse. They are canceling each other out, so there is no action. It's just what you began with, it's x. So 1 plus the inverse function cubed to the power of 1/3 will be the input. Do you understand? That's as simple as it gets. It's not even thinking here. It's just implicit differentiation. So now observe that what we see here is, what is y plus y cubed? So we see this 1 plus y cubed to the power of 1/3 squared divided by y squared. Can anybody tell me in this square brackets, what can I replace the square brackets by? If you followed, the square brackets are identical to x. Of course, that's the original function. Do you see, guys? You don't lose track of it. Do you see this? It's just x. So I can just write this right now as x squared divided by y squared. So the numerator is x squared. I can write it this way. So the answer is x squared divided by y squared. So in other words, the answer, the derivative of the inverse function of x is x squared divided by the inverse function of x squared. And if I, of course, want to, I can obtain a formula for the inverse function, right? So if I want to simplify it further, I can, of course, because remember, my function f of x is equal to the cube root of 1 plus x cubed. So what is the inverse function? So what I do is I say if y is the inverse function of x, then what we have here is x equal to the cube root of 1 plus y cubed. So I cube this x, so it's x cubed minus 1 equals, so it's x cubed minus 1 equals to y cubed. So y is equal to the cube root of x cubed minus 1. Yes? So if I want to simplify it further, the answer is that the derivative is x squared, and in the denominator I have the cube root of x cubed minus 1 to the power of 2. Is this clear? Let me give you one more example. Why not? You see, when clear, just which steps aren't clear? Okay, Junaid. Which step is not clear here? The start? In the beginning, there was darkness. And in the end, there is darkness. This is the function. I ask you to find the derivative of the inverse. Now, I can accomplish this using implicit differentiation. So you agree that there is no formula for the inverse function that we have found. We have a formula that we can differentiate for the f of x, but not for its inverse. Do you agree with me? Which means that I can set y equal to the inverse function, pretending that that I figured out what's the formula that I'm going to differentiate. So I'm using implicit differentiation. I'm saying y is the inverse function. So far, good? It's just a labeling. It's like Francis, why can I label you as X? Or why can I call you Francis? Better said, right? I mean, you're asking me why can I call you Francis? I can give you so it's just a labeling. So it means nothing more than I just say, okay, well, this expression I'm gonna call it Y. So what is true about what Y stands for? It's true that if I apply the formula for F to Y, then by virtue of what it represents, I should get the input. So F of Y is X. And then this formula I can differentiate. Here is the derivative to the extent I can carry it. I just do not know the derivative of Y because it stands for a formula that I do not see. So it's Y prime here. So then I solve for Y prime. It's 1 over 1 plus Y cubed to the power of minus 2/3 times Y squared, which becomes, if I flip it, as 1 plus Y cubed to the power of 2/3. And I recognize that this looks like 1 plus Y cubed to the 1/3 squared divided by Y squared. So the numerator is right away simply X squared. The denominator here, Y squared, I don't have a formula for Y. So I just write it as X squared over F inverse squared. For this particular problem, since it's possible to come up with a formula, the answer is still not simplified if I left it in Y, right? I mean, at least, I mean, you can, depends what you have to do here. I said it's related to the inverse, but I did not say, what do you mean where dy dx went? Dy dx is the derivative. I took the derivative and it's accomplished. So here I do decide to give a formula for F inverse at the very end because I see I have a Y squared in the denominator. You agree? So what do? I solve for what is the inverse function, and I obtain this formula. So it's X squared divided by this formula squared. Let's try one more. All right, guys, so here is a function f of x. So it's going to be the fifth root of 1 plus e to the x. Okay? I want you to tell me what's the derivative of the inverse function. And I want you at the end of the day to simplify it and get it to an expression only involving x. So I want to see several layers of solution for this one. Well, you're supposed to find the derivative. It's clear what you have to do. You have to find the derivative of f inverse of x. And the rule, Karen, Francis, I haven't seen you in a while. Robert, would be nice to see you. Gian, Faiza, turn on your cameras. We're beginning to have less than 10. I don't like that. Cameras on. Jetlo, Zayad. Thank you, Joseph. All right, David, thank you. After you're done with that, see if you can simplify it further. Gianni Fang, by the way, you're here? Faeza, are you here? Good. Barbara Dayan, Zayad. All right. Are we ready? No, it doesn't look like we're ready. All right, it should be very quick. Look how we do this. What's the first step? Would you let me know? First of all, how would you begin it? You can do that, well, so you can do that like this, sure. You can say, let's just make it 1 plus e to the x to the power of 1/5. It's the same thing, it's not really a step. But then what do we do? This is just writing the same thing in a different way. You can do that if you like. What do you do now? Yes. So then very simply, we don't have a formula for this F inverse. Yes. So we don't have this formula for the derivative. So we are going to say, okay, y is the inverse map. And then if I apply the function to y, so f of y, on one hand, it will be f of f inverse x, which is x. On the other hand, if I plug y into the expression, it's just 1 plus e to the y to the power of 1/5. So this first step, everybody understands what happens here. I'm just creating an equation that identifies what y is as a formula. So I'm using implicit differentiation here. Yes, it's implicit differentiation. So then I take the derivative. And when I take the derivative of this expression, on the left side, I get 1/5, 1 plus e to the y to the power of minus 4/5. Do you agree? Do you agree? And what is that equal to? And then, of course, the derivative of e to the y of the inside is e to the y prime. Don't forget that. The e to the y prime, you see where it comes from. It's implicit differentiation. And this is equal to the derivative of x, which is 1. So it should not take long to get to that step. Now, what's the result? Now, I can see that I'm going to multiply everything here. First of all, I'll multiply everything by 5 and the reverse of that. So I will see, for instance, e to the y prime equal to 5, 1 plus e to the y to the power of 4/5. Agreed? To the power of 4/5. Because I multiplied. You see, it was minus, but I multiplied by plus 4/5 on both sides. That's how I got rid of that. And I multiplied by 5 and I multiplied by plus 4/5 to get rid of that. And so what is y prime? So y prime is 5, 1 plus e to the y to the power of 4/5 divided by e to the y. We agree? Now I can do one step better here already. You see, so I mean, this is now in terms of y. Let's see how much can I do better. So first of all, do you see 1 plus e to the y to the 1/5? is x. So what do I get? I see that my answer is y prime 5x to the power of 4 over e to the y. So far good? Do you see how I transitioned to x to the 4? I'm trying to make it as explicit as possible. Now, this e to the y, I'm not going to be able to reduce unless I'm able to solve for the inverse function. It's not always very easy to solve for the inverse function. It could be extremely, extremely difficult, but not in this situation. Remember that we had 1 plus e to the y to the power of 1/5. That's supposed to equal to x, which means that 1 plus e to the y, 1 plus e to the y is equal to x to the power of 5. Do you agree? And I don't really need to solve for y. Do you see what I need to solve for, guys? I need to solve for e to the y. I don't really care about y. So what is e to the y? E to the y is x to the 5 minus 1. You follow? So what is my formula there? So it's so I just replace e to the y here. So it's 5x to the 4. So my derivative, the derivative of the inverse function, is 5x to the 4 divided by e to the y, which is divided by x to the 5 minus 1. And I'm done. That's my derivative. Was it difficult? It was not difficult, correct? Let's do one more, since it should take you guys, what, 2 minutes to do such a question. So let's suppose that my function f of x is e to the power of x plus 1 divided by x minus 1. Okay, that's my function. I want you to tell me what's the derivative of the inverse. Marwa Rahman, are you here? Marwa Rahman. Good. All right, thank you, David. We shall see. Justin, thank you. So why am I not seeing answers? How long does it take? What do? We say y is equal to e to the x plus 1 over x minus 1. I mean, sorry, y is equal to the inverse function. Yeah, which means that that e to the y plus 1 over y minus 1 is equal to x. That step everybody did correctly, yes? Next, I can take the derivative. I mean, I can do many things actually. I can solve it from the very beginning or do the derivative, you see? So what is y? I can solve for instance, I can do instead of going through the implicit differentiation, I can actually find a formula for y. So here I would say y plus 1 over y minus 1 is equal to ln of x. Do you agree? The logarithm is the inverse of e. Everybody understands that. We talked about it, I think, a few times, right? A to the power of logarithm cancel out, so they are each other's inverses. So what do we have next? Next, I can, if I prefer, write it into 1y. I can write this as y minus 1 plus 2 divided by 1 minus 1, which is simply 1 plus 2 over y minus 1 equal to ln x. Yes? Which means what? Which means that my function is just move things around, so and flip, so it's ln of x minus 1. So ln of x minus 1 is equal to 2 over y minus 1. So flip it over, that means y minus 1 is equal to y minus 1, if you prefer, over 2, equal to 1 over ln x minus 1, which means that y is equal to 2 over ln x minus 1 plus 1. Yes? This is my formula for y. So my inverse function, I can even solve for it. It's 2 over ln of x minus 1, was it? Minus 1 plus 1. And then I can take the derivative of this function if I want to. So the derivative of f inverse x, that would be what? That would be 2 over ln x minus 1 squared with a minus here times the derivative of ln x. Could anybody tell me what's the derivative of ln x? Derivative of ln x is 1 over x. So this entire thing times 1 over x. We're done. Yeah, so the answer is simply minus 2 over x ln x minus 1 squared. The 2, so it was y plus 1. I want to divide by y minus 1, right? So I would like them to be, I would like here to be not a plus 1, but a minus 1. So I write y minus 1 plus 2, because I have to pay for what I want. Do you see? Here I cross out. And do you understand what I accomplished by doing that, guys? By doing that, I have fewer instances of y. You could do it in many other ways, but here I decided to get rid of one of the y's. I used to have y in the numerator and in the denominator, and now I only have one y in the denominator. Do you see, Joseph, how that helps? Good. So this is the answer. Here, guys, we are going to now derive formulas for the using geometry. Do you remember the more complicated? It's not more complicated. It's just, I mean, you need to train your mind. Like some people ask me all the time, what do you do it for? It's almost like asking, why do you do push-ups for? Or what do you pull up? Or what do you run? I mean, it's supposed to train your brains, right? It's supposed to be some medicine against being stupid, if it, of course, works. So I want you to tell me, first of all, by explaining geometrically, guys, let's try to understand, or geometrically, or do it any other way. I want you to tell me, first of all, what is the derivative of ln of x? Let's remember why that is was the derivative. What's the derivative of ln of x? I know you know it, some of you. But why is the derivative such? Okay, we are going to do it once in two ways. Okay, for the ln of x, I'll do it in two ways. I will give them more geometric reason, and I will do it like we did before. But what's the derivative of ln of x, please? Solve it to the best of your ability. And by the way, don't write me the answer. I know you know the answer. Tell me what you're going to do. Give me 2 steps of what you will do to solve this question. 2 steps. If you write me 2 steps, I will know that you know how to do that. Two steps. 2 lines. One something you do, and then second thing you do. And if you give me those 2 steps, you don't need to write more. What's the first thing you do? One way you can do that is implicit differentiation. So you can just do this little thing. Y equals to ln x. Presuming we have one function, we know how to take the derivative, but that's not ln x. We haven't in this class described the path to derive ln x directly. What's the next step? ln x is the other side of what function? Ln x looks like another function altogether. Yes, Gian. E to the y equals x. Those are the 2 steps I wanted you to write. Was it difficult? The next part is e to the y equal to e to the y equal to x. You see why is that a good strategy? Because I see ln x and e to the x as one and the same thing. We're going to do that yet one more time afterwards. Ln x and e to the x are exactly the same thing, viewed geometrically. When we take derivatives, we're zooming in on a curve and seeing a tangent line. So viewed geometrically, there is no difference between the graphs. Do you understand that? That's the deep insight that we have there. And so doing that, we can write e to the y equals to x. The next part is that we take the derivative. Y is this function that we want to take the derivative. So the derivative is e to the y prime equal to 1, which means y prime equal to 1 over e to the y. But what is e to the y? E to the y is written right over here. Yes? E to the y is written right over there. So what do we get? we get 1 over x. 1 over x. The derivative of ln x is e to the x. Are we understanding it? So write yes if you understood how I solved it. You understand? There's not there are no steps. It's like step 1, do this. Step 2. You are not a machine. You are not a robot that I'm programming. You are thinking, I presume. And what's the idea here? The idea is that a ln curve and e curve are really the same exact curve. Do you understand? I just view it from a different perspective. Can you view things from a different perspective? That's a very, very interesting question. Now, would anybody tell me what's the meaning of the 1? Why is it 1 over? Any ideas? Why is there a 1 over? Do you see that we got here 1 over e to the y? Why is there a 1 over? Yes, maybe. I mean, technically, yes. You see, there is a technical aspect of it. It's just what happens mechanically, but there is a meaning to it. Why is it 1 over? What's the reason it's 1 over specifically? It's always going to be 1 over something. All right. So then we try to think about what cosmonauts are seeing. What are the cosmonauts seeing, guys? So what's the why did I think to do this property? I mean, I could have thought of it by implicit differentiation purely formally, but I could have also looked at the geometry. You see, that's what I try to explain with the astronaut analogy. So you see, here is what we have here. Here is my coordinate system, and this here, let me draw it in blue. This is the curve y equal to ln x. You with me so far, guys? I mean, the fact that I drew this curve this way doesn't matter. I mean, I don't really need a curve. I don't need to see it to be able to figure out a formula. I just give a sort of visual assistance. So it's y equal to ln x. What is that? What's the meaning of that curve, guys? If this is the x-axis and this is the y-axis, then it means that the relationship between the coordinates is x ln x. Yes? But I can describe this relation. This means I describe this relationship in terms of the first coordinate. You see, this is the description of the graph in terms of the first coordinate. So I will place now a person on the x-axis. My cosmonaut is doing a spacewalk on the x-axis. So he plants a flag here at position x, and he observes this regularity at position x. The corresponding position is ln x. That's what it means. Do you agree? Now, if I place another astronaut doing a spacewalk on the y-axis, and on the y-axis he places, for him, he describes it in terms of the second coordinate. He places a flag right over here. So his flag is placed in position y. You understand? The flag is placed in position y. What is the altitude? So for the green person, the altitude is where the red flag is. What's the altitude? You follow what I'm asking in this formula? In other words, he describes the same relationship this way. He describes it from the perspective of the second coordinate. From the perspective of the second coordinate, if this is a number for the second coordinate, what is the number of the first coordinate? Are you with me? You see, it's a matter of this, guys. If I am shorter than Michael Jordan, then I say, oh, you are taller than me. and he would say, you are shorter than me. Do you understand? It's exactly that same. It's just a relative point of view. So the astronaut walking on the x-axis describes the graph from the point of view of walking on the x-coordinate. And the astronaut on the y-axis describes the same thing, but from the point of view of walking on the y-coordinate. So if this is y, what is the first coordinate? E to the y. Very good, David. E to the y. It's so simple, guys. Do you understand that they are describing the same thing? From a different point of view, they are describing exactly the same thing. And it's your job to understand that you're describing exactly the same thing from 2 points of view. Yes? Why is that the situation? Again, if you don't see it, guys, this if I say y is equal, here it is, y is equal to ln x. That means that if I apply the inverse function, e to the y is equal to e to the ln x, which is x. Do you see what I just did? E to the y is my x coordinate. It's just an ability to see that. So then we know how to take the derivative of e to the x. Do you understand? What are they actually trying? When we are asking for the derivative, they are trying to determine a slope of this line from a particular perspective, right? So here is a line. The fact that this curve is differentiable, do you see the idea that this curve is differentiable is just to say that when you zoom in on the curve, it looks like a straight line. That's all it means. You understand? Differentiable means that it looks like a straight line. And when you ask for the derivative, you are asking for the slope. You follow, guys? And this is a very arbitrary question. What is it asking for the slope? It's asking to for a person standing on the x-axis to describe the incline. You see? So when I ask for the slope, I want to know this. I want to know rise. Well, I'll just do it like this: rise over run. So this is dx and this is dy. dy is the rise and dx is the run. So I am just interested in calculating dy dx. Yes, but dy dx is not the easiest thing to calculate because this curve is more familiar to me from this perspective. From the perspective here where dy is for the guy walking on the y-axis, his horizontal is dy and his vertical is dx. Now, what do I have here? I have that the x is this. Here is my x, right? So dy of e to the y is equal to e to the y. Same number. So what is this guy saying is the slope? He's saying the slope basically is saying that dx over dy is equal to e to the y. It's equal to e to the y. What is e to the y? It's the vertical position. So he's saying that the slope is equal to x. You see? That's what he's saying. Are you with me? All it is just a matter of perspective. You have to not look at the symbols, see what are they talking about. So this guy, because from his perspective, his vertical is e to the y. So for him to measure the slope this way, it's much easier. Dx over dy is the slope of e to the y, and we already know how to find that. So he knows how to find the slope from his perspective. From his perspective, the slope is x. It's the vertical position, his vertical position. You understand? So for the green guy, the vertical position is just x. Are you following? And then finally, then this guy is now reporting. What is the slope from the point of view of red? Is what? Do you understand? The slope from the green point of view is x. What's the slope from the red point of view? So it's 1 over the slope, exactly, Jahin. It's 1 over that slope. Do you see why 1? Because they have opposite notions of vertical and horizontal. What is vertical for the green is horizontal for the red. Do you follow? Astronaut green, for him, vertical is what's for the red, horizontal. They just have a different perspective of the same curve. You see, they are watching the same curve, but they are describing their point of view. And so what the red can do, he can use the assistance of the green person to understand the curve from his point of view, and then right away know how to convert it to his point of view. Do you understand? Because the only difference between their point of view is that they have reverse notions of vertical and horizontal. Are you with me? It's a bit more challenging, but this is much smarter than what we did before. It right away tells you that if a function is differentiable, then the inverse is differentiable. Do you see why? Because if the curve is approximated by a line, viewing it from another point of view would also make it approximatable by lines. It makes, if the curve is chain of lines from one point of view, it will be chain of lines from another point of view. Yes? So the answer is what? So from the red's point of view is 1 over, I'll write it like this, green. Right? 1 over green. Because it is 1 over dx dy. Which is then giving me 1 over x. We solved it. Are you getting it, guys? You can solve it, at least you have to solve it using the implicit differentiation. But if you get what I'm saying now, you are far smarter. Now, I want you to tell me, if you understood this, I want you to tell me, first of all, let's recall, what is the derivative of any thing of the form a to the power of x? And recall, I mean, I want you to not just look at it online, I want you to tell me how do you figure the formula, please. How do you figure the formula? I want you to write 1 or 2 lines to indicate that you know how to figure the formula. I don't care that you can look something online. Just like you can look at somebody doing exercises online, right? Push-ups, pull-ups, or whatnot, right? It doesn't mean you're strong. Show me that you're strong. Derivative of a to the power of x, please. 2 lines. Not even the formula, 2 lines. What do I do to figure it out? Right, Mary Carola, take care. Two lines. Yes, but the line to show me that you derived it and not looked at it. It's very simple. What would you prefer to see here, guys? It looks like exponential function. What do you prefer to see? Yes, you prefer to see e, so why not place e there? It's a common strategy. So it's the derivative of e to some power. But I have a to the x. So if it's e to some power, I will write ln a to the x. Do you agree? Do you see why I did e to the power of ln of a to the x? Because I don't have an e and I want an e. And e and ln, they cross each other out. You see, guys, it's a matter of knowing what you would prefer to see. So then what do you get? It's the derivative of e. You can move the x out. So it's ex ln a. And what's the derivative? The derivative is simply by chain rule ex ln a times ln a. Agreed? Do you see why the change? ln a is just a number. It's factored out here, yes? And so what is ex ln a? It's what I began with. You see, it's just this same expression. So it's a to the x ln a. Yes? Now, if you understood this, I want you to tell me what is the derivative of logarithm base 3 of x. Do it very quickly. The final answer is a, where is it? Is a to the x ln a. Now I'm saying find the derivative of, so here I'll write it here so that you don't have to, but look at it yourself, guys. The derivative of a to the x is a to the x ln a. I want you to find the derivative of log base 3x. All right. The answer can be obtained this way. So you set y equal to log base 3x, and so then 3 to the, that's the same as 3 to the y is equal to x. Do you agree? 3 to the y is x. What's the derivative of 3 to the y? It's 3 to the y ln 3 y prime is 1. So y prime is equal to 1 over 3 to the y ln 3. 3 to the y is x, so this is just 1 over x ln 3. Done. All right, let's do those exercises. I want you to calculate the derivative of ln of x squared plus sine x. So do this one. Okay, Joseph. Good. All right. All right, so that should be solved already. So what's the solution? The solution is take the derivative of ln. What you get the denominator, which is x squared plus sine x. And in the numerator, you get 2x plus cosine x. Yes? Now, of course, don't wait and solve the next one. So solve problem B, please, and quickly. So B and C, come on. So come on, why is it taking so long? For B, what's the derivative? The derivative is 5 log 3x plus x times ln 5 times 1 over x ln 3 plus 1. Yeah, I'll show you more precisely. Here it is in B. You see this line? All right, do C and D, please. Yes. Let's see. Guys, can you solve C? Can you solve D? And think about it, you can use some properties of the logarithms, right? You know something about logarithms, presumably. You realize that on the final exam, you have to do it very fast, yes, guys? And the questions are much harder. What's the derivative of a quotient? Just take the quotient and take the derivative separately. What's the problem? Square this thing, then copy it to the top. Take the derivative of log base 5 of 3x, which will be what? By the chain rule, it's just 3x ln 5, and then do the same thing. Now for the last question, don't start taking the derivative. No, I mean actually, so you see guys, it's log base 10 e to the 5 e to the x. If you want to, you can drop the 5 e to the x in front. You can take this power before taking the derivative and move it in front. So you can, for instance, if you prefer, you can take the derivative of e to the 5x. Five e to the x log base 10 of e, and that is just a constant. Right, log base 10 of e is a constant, so it's just like the derivative of 5 to the x, so just 5 e to the x times log base 10 e, which is the same thing. It's equal to the same thing, guys. The derivative of this expression is equal to itself. Isn't that interesting? Let me just ask you this question, guys, since we're on it, right? So the derivative of log base, I don't know what is it, base 10 of e to the 5x, so e to the e to the e to the 5x, right? is equal to the derivative. You can see I can take it out, so it's e to the 5x log base 10 of e, which is equal to, just look at it, this is a constant, it's equal to 5e to the 5x log base 10e, which is equal to 5 log base 10 e to the 5x. Can you tell me, what do you think is this function? Does it have a much simpler looking formula? Because do you see what happened here? The derivative of this function was, what happened here? The derivative of this function happened to be 5 times the function. Yes? The derivative of this function is 5 times this function. What sort of function is this then? Any ideas what it might look like? What's a sort of simpler formula for it? Which, by the way, you can obtain by changing bases. A derivative of a function is equal to 5 times the function, means the function is very good, Zakaria. The function is very similar. So this function, as far as I know, it's some constant times e to the 5x. Something like that. Now I can actually use change of basis, you see. I want here to be e, right? I want it to be e. You see, guys, in this function I have log base 10 e to the 5x. I would have preferred this to be better log base e, or better ln. I would prefer ln rather than log. Yes, and then that's very useful for me then to look at the change of basis formula. Do you remember, guys, the change of basis formula? So how do I convert from log base a to log base b? How is the conversion going to happen? Well, this is how we do that. Look at it. So if I have log base a of x, yes, I want to convert it to log base b. What do I know about this function? I can say this is equal to, I can say it simply like this. To compare, to understand how to change it, I can say that simply a to the power of log base a of x, that will equal to x. Do you agree? But I can switch. I can write, for instance, that a is equal to b to the power of log base b of a. And then this is to the power of log base ax, right? Is equal to x. And what is x? X is also the same thing as b to the power of log base bx. Yes? So I have the following property. I have the property that, you see the product. So I have the property that log base b of a multiplied by log base a of x is equal to log base b of x. You follow? So what is log base a of x? So that means that log base a of x is simply log base b of x divided by log base b of a. I can easily convert one logarithm to another. Every logarithm can be solved in terms of another. Do you follow how I solved it? Very simple. I just convert, I convert the expressions and make them equal. And so what happens in our situation? So for instance, log base 10 of x will equal to ln of x divided by ln of 10. That's what this means in our case. So that means that log base 10 of e to the power of e to the power of 5x will be the same thing as ln of e to the power of e5x divided by ln 10. And what is ln of e to any power? It's just 1. So the answer is that this is e to the power of 5x times 1 over ln 10. So just as we predicted, the function is very similar to e to the power of 5x. Clear? It looks by your face is extremely clear. If you are interested, we're going to end the lecture now. If you are interested, then we can watch a question about what when we're about Americans. See if you understand Americans well. And if not, goodbye.